what are the angle bisectors. Suppose here we have a triangle ABC. Here, this is a triangle ABC. This triangle has three sides AB, BC, and CA. These three sides, and it also have three angles. Measurement angle A here at vertex A, measurement angle B here at vertex B, and another angle measurement angle C here at vertex C. So this triangle has three angles as well. Okay. Now, what are the angle bisectors? Actually, angle bisector is a ray which divides an angle into two equal parts. That ray divides the angle into equal parts. That ray is called angle bisector. Okay, look at here. If this angle A, if we divide this angle into two equal parts by drawing a ray like this is a ray coming from point A, and it is bisecting the angle A into two equal parts. Okay, this one and this one. So this ray from point A, this is called angle bisector. Similarly, here this angle C will be bisected by this ray coming from here as it passes through and intersecting the first ray here at this point. So this is also an angle bisector which divides this angle into equal parts. Okay, so a ray which divides an angle into two equal parts, that ray is called angle bisector. Similarly, the third one, when it divides this angle B into two equal parts, and it comes and also passes through the same point. This is the point where all three angle bisectors meet. This point is the concurrent point of these angle bisectors. The line segment joining the vertex to the opposite midpoint of the opposite sides. Joining a vertex to the midpoint of the opposite side, this line segment is called median. Here three medians are drawn, and the point which is concurrent point of these median, it has a specific name. Its name is centroid. Centroid. Okay, the point where three medians of a triangle intersect each other, this point is called centroid. Similarly, the point of concurrency of three angle bisectors is called incenter. It is called incenter. Okay. Well, students, look at here. Here is another triangle. If I give it a name XYZ. XYZ. This is a triangle XYZ. If I draw the right bisectors of this triangle, like right bisectors are those lines which passes through the midpoint of a line segment and are perpendicular to that. Okay, like this. Here it is perpendicular to this XZ. This is the right bisector of XZ. Similarly, right bisector of this XY will also pass through this point, and the right bisector of this one, it will also pass through this point. So these are the right bisectors, and these right bisectors, when they meet each other at a single point, this point is called circumcenter. For right bisectors, the concurrent point is known as circumcenter. Similarly, if we draw an other triangle here and we check out its altitudes, altitude is that uh, line or ray which is which is up which is drawn perpendicular from the vertex to its opposite side. Here this is the vertex. If I say it, this is triangle ABC. So this vertex A to the opposite side BC. When we draw a perpendicular from A to the opposite side BC, this one is called altitude. Okay. Similarly, from this vertex B to this line AC, if we draw a perpendicular, if we draw a perpendicular to this line like this from B, it is an other altitude, and similarly from C we draw an other altitude which also passes through the same point here. This is perpendicular as well. Here these three rays which are coming from the vertex, opposite vertex to the opposite side, vertex to the opposite side, and these are perpendicular. These are called altitudes. Okay, so altitude is a ray or a line which is perpendicular from the vertex to the opposite side, perpendicular from the vertex to the opposite side. This is called altitudes, and the point of concurrency of the altitude is called orthocenter. This point is called orthocenter. Orthocenter. Okay, and similarly this point for the perpendicular bisector, that is called circumcenter. Circumcenter. I hope you have now better idea about these four types of specific concurrent points. Okay.